let's see, as far as talking about derivatives, we talked about product rule, we talked about quotient rule, I made you practice some of those things with trig functions. So we're going to start with kind of an interesting, not terribly interesting question, but I want everybody to do this. So if I give you y is equal to 3x plus 1 squared, I want everyone to write this down and take the derivative. I'm going to hit pause. All right, so I want to talk about kind of the progression of what we're doing and where people tend to get in trouble in math. Have you ever taken a math test and you're not quite sure what to do, and so you say, well, I think I can do this? Like when you're trying to work out a math problem, and what ends up happening is you're not sure if it's legal or not, but you're going to do it anyway, right? That's kind of a dangerous place to be, because sometimes you get it right, but more often than not, you might get it wrong, because you're still questioning, what am I allowed to do versus what am I not allowed to do. And one thing that I try to do, particularly in this course, and actually in this sort of when we're doing these topics, is I want to talk about what you know versus what you don't know, right? And right now, up until today, life is simple, relatively simple, because what you know is if it's like number x to a power, that's what you know. Right? You know if it's number x to a power plus number x to a power plus number x to a power, that's pretty much all you know. If you've got a fraction, and then we talked about when you multiply things, then you have product rule. When you divide things, you have quotient rule. And you know how to handle it when it looks like those things. This does not look like those things. And so if this doesn't look like what you know, you have to change it to make it look like something you know. So up until this point, you don't know how to take the derivative of it looking like this. So we've got to do a little bit of algebra. Not much, right? We square it, so that's going to give us 9x squared plus 6x plus 1. And now I can take the derivative. Right? So if I take the derivative, that's going to give me 18x plus 6, and now I'm done, right? And now this is the derivative. And had you tried something else, you may not have gotten this answer, right? But I think everybody can agree this clearly equals this, and this is an easy derivative. And since this is an easy derivative, we know this has to be the answer, right? Now, okay, so if I give you something that looks like this, right now you have to make it look like this, and then take the derivative. I'm going to write the answer to this up here. So that's 18x plus 6, because I'm going to reference it in a little bit. All right, that's fine. But what if I give you y is equal to 3x plus 1 to the third and say, take the derivative? What do? And you go, well, fine. I'll multiply that out, right? I don't like it, right? But we could multiply that out, couldn't we? And then I go, oh, wait. No, I didn't want this to the third power. I wanted this to the 13th power, right? At which point we realize, okay, you could multiply this out. You need a much bigger board, right? And a whole lot of time, and hopefully you didn't make a mistake. But we obviously don't want to multiply this out to take the derivative, right? Because that would be ridiculous, right? So there's got to be a better way. And there's got to be something else. And this something else is called chain rule. There's not a too complicated, the proof isn't too complicated, but it's never been productive for me actually to do the proof of it. So what I'm going to do is, today is all about how do we, first of all, what the chain rule is, how do we do it, and sort of apply it in different areas. And here is the key to chain rule. The key to chain rule is you look at something and you use the word stuff appropriately. So when I look at this, I see stuff to the 13th. Can you look at that and see stuff to the 13th? It's very important to use the word stuff, okay? If you can use the word stuff appropriately, you're going to be awesome at doing chain rule. So when I look at this, I see stuff to the 13th, yay. Now, here's what chain rule is. If you see stuff to the 13th, let's think about what the derivative is. Well, if I have stuff to the 13th, you think, well, the derivative of that is 13x squared, right? And the derivative of stuff to the 13th, 13x squared. Well, that's what we do here. I'm going to say this is 13 stuff squared, right? Because, I mean, that's how we take a derivative. I see stuff to the 13th, 13 stuff to the squared. So I'm going to put my stuff in here, which is 3x plus 1. And here's the chain rule part. The chain rule part is anytime you use the word stuff, you have to take the derivative of stuff and put it out here. And so in this case, the derivative of that 3x plus 1 is 3. And so this is my derivative. Right? So I'm going to go over it again. When you look at something and you can say the word stuff, right? So I see stuff to the 13th. Then when I take the derivative of it, it's going to be 13 stuff to the 12th, subtract 1. But I said the word stuff, and anytime I say the word stuff, I have to take the derivative of the stuff, put and multiply it on the outside. Of course, to clean this up, is this times this gives me 39 times 3x plus 1 to the 12th. And there's my answer. Okay? So now let's go back to this problem. When I look at this problem, can you see stuff squared? Right? Hopefully it's obvious. You can look at this and say, okay, that's just stuff squared. And so if this is stuff squared, that's going to give me 2 stuff to the first, right? 2 times this, stuff to the first. My stuff is 3x plus 1, but I use the word stuff, right? Because when I said 3 stuff to the first, I said the word stuff, so I have to take the derivative of the stuff, so that's going to give me a times 3. And when I clean this up, I end up with this is 6 times 3x plus 1. And if I distribute, that's going to give me 18x plus 6, which, oh, good, is the same answer I had when I did it the other way, because if it didn't, I'd be in trouble. Okay? So does that kind of make sense, right? So this, in a nutshell, is what chain rule is, right? All chain rule is that when you read a problem, you can say the word stuff. Officially, it's like composition of functions, and there's some notation that I'm going to get into probably tomorrow, but today is all about what the heck is chain rule and how do we get the right answer. And then, unfortunately, this makes our life harder, right? Because now I start incorporating everything else we've done. When I start incorporating everything else we've done, then it gets a little ugly. So let's try one. Let's say, so write down y is equal to 3x plus 1, the square root of 3x plus 1. All right. Well, when I see this, my first instinct is I see square root of stuff. And since I see square root of stuff, that means I'm going to write this as 3x plus 1 to the 1/2. So now this looks very close to this, right? Like I have stuff to a power. I like stuff to a power. And so my derivative of this is going to be, let's see, pull it down, that gives us 1/2 stuff. Subtract 1 from that, I get a negative 1/2. And I should have changed colors. Sorry. Every time I say the word stuff, I need to change colors. Right? You don't need to, I do as a teacher, because I want to. The trick to doing this is making sure you're focusing on the right part. So I do 1/2 stuff to the negative 1/2. I said the word stuff. Oh, I better take the derivative of stuff, which is 3. And now I've taken the derivative. So now we have to clean up. No negative exponents. And we've already got a fraction. That 1/2 is a fraction. So I'll go ahead and put that division bar here. There's the 2. This goes in the bottom. So that's going to give me 3x plus 1 to the 1/2. That's on top. And since we started with the square root, I need to end with the square root, so that's going to give me 3 over 2 times the square root of 3x plus 1. Okay. So, same problem, right? Numbers are a little uglier, right? I have to rewrite it as stuff to a power, but I say the word stuff. All right? Now your turn. What if I gave you y equals 3 over x squared plus 1? And I'll give you a hint. I'm going to rewrite this to the first. And your challenge now is rewrite this to make it kind of look like that. No. The key to taking the derivative of this is kind of make it look like this. So if I'm going to rewrite it, I'm going to rewrite this as 3 times x squared plus 1 to the negative 1. Now this is starting to look like this part. And when I see this, I see 3 stuff to the negative 1. And since I see 3 stuff to the negative 1, then my derivative is going to be, well, negative 3 stuff to the negative 2. But I said the word stuff, and since I said the word stuff, I need to take the derivative of this, which is going to give me a 2x. And let's see, that means this is going to go on the bottom. This times this is going to give me a negative 6x on top. And then I get an x squared plus 1 squared on the bottom, and there's my derivative. Now, so for the most part, that's chain rule, right? You identify when you have, the official title, the official vocabulary is anytime you have a composition of functions, you have to use chain rule. As far as in practice goes, I want to make sure you say the word stuff. So you rewrite it because you don't like fractions, so we rewrite it without fractions. And when you rewrite it without fractions, I say, oh, I have 3 stuff to the negative 1. And once you get it to look like this, you're fine. Okay, so how does this make your life harder, right? This seems like it's making your life easier. Well, now I have to start combining it with things that we already know. And this is where things begin to get ugly. See, what if I give you y is equal to x squared times the square root of 1 minus x squared? I'll give everybody a little bit of time to write that down. Right? Well, do you see them multiplying two things together? You've got two things that are multiplied together. One has a x, but then both of them have an x. I'm going to draw my little line to say this is product rule. And when I draw my little line as a product rule, this is my f and this is my g. And so now, to take the derivative, well, f prime, that's pretty easy. That's just 2x times the g, which is the square root of 1 minus x squared. Right? There's the f prime, there's the g. Plus, now I need to take the derivative of this. Okay? Because I need my g prime. Right, so what is my g prime? Well, my g prime, let's see, I'm going to rewrite this and say that's 1 minus x squared to the 1/2. And when I look at this, I see that I have stuff to the 1/2. And since I see that I have stuff to the 1/2, that's going to give me 1/2 stuff to the negative 1/2, right? Because I got to subtract 1. So this gives me, my stuff is 1 minus x squared. I said the word stuff, so I need to take the derivative of this. So it's going to give me a times negative 2x. I did not judge this properly. This whole thing is g prime. which means I'm missing my f, which is this x squared. And here's the f. Pause for just a little bit to try to catch up. But do you see what happened? All right, and actually what happened is a problem that started off this big got this big real quick. Okay. And the part that we're really not going to like is that thing that's this big, we've got to make it this big. We've got to clean this up. So how do we go about cleaning it up? Well, really nothing I can do with this. But this side I can do some work. Like obviously I'm going to get a negative 2x cubed. That's going to go on top. This is going to go on the bottom. So I'll just go ahead and write that down. I get a, well actually I think I can go ahead and, yeah. So I'll put the negative 2x cubed on top. This goes in the bottom, so this is going to give me the square root of 1 minus x squared. And then there's a 2. That's looking better. And this thing is going to give me 2x times the square root of 1 minus x squared. And there's a plus. So all I did was clean this up a little bit. But there's more cleaning up to do. See? I can cross those 2's out. Right, that's better. Right? And here is the part that, to be honest, the AP exam doesn't care so much about anymore, but your college professor will. And actually, maybe I will care a little more at the end. I need to combine this as one term. I don't want to have this as two terms. Right? And there's two ways to do this. The sort of the standard way that a lot of textbooks use, and actually the way I was taught, is I was told you factor out a 1 over square root of 1 minus x squared. You can factor that thing out, which technically you can. But what I found is that when I try to teach it that way, it gets really confusing. The easier way that I have found that works it has a lot more, it gets a lot more traction, is get a common denominator. And what I'm going to do is guarantee anytime you get a common denominator with radicals, the numerator ends up being very, very nice. Right? And we're going to see some examples. This is a pretty basic example, and then at the end, near the end of class, you're going to see a more complicated example. But the numerator still turns out being pretty nice. So, what do I mean by that? Well, what I mean by that is, okay, I got a common denominator. I've got a denominator of 1. So if I'm looking, if I want to get a common denominator, I'll have to multiply top and bottom by the square root of 1 minus x squared. All right, I can do that. I'm going to multiply top and bottom by the square root of 1 minus x squared, square root of 1 minus x squared. And here's where things get nice. First, the denominator is still just going to be the square root of 1 minus x squared. That one's not that bad. Let's look at the numerator. Let's see, the right-hand side is just going to be a minus x cubed. But let's look at this left-hand side. See, I have square root of something times square root of something. The same thing, that just means I'm going to get that something times a 2x. And oh wait, that gets even simpler. Because if I distribute the 2x, let's see, I get a 2x minus 2x cubed. And I get, when I clean up the top, I end up with 2x minus 3x cubed all over the square root of 1 minus x squared. And this is the issue most people have with calculus. Here's the calculus step. where we did the product rule, we had to use the chain rule and all that. This was the calculus step. Everything after the calculus step was algebra. And what you're going to find is pretty much every problem that we do for the entire year is going to be some algebra, a little bit of calculus, and then a whole lot of algebra. And that's how all of these problems work. All right? Let's look at another one. So let's say I give you y is equal to 3x minus 1 over x squared plus 3 cubed. Maybe give everybody a chance to write that down. All right, so how do you approach it? Well, when I look at this, I see stuff cubed. Can you look at this and see stuff cubed? I mean, that's the important part. You need to be able to look at this and say, oh, that is stuff cubed. Do we know how to handle stuff cubed? Yeah, we know how to handle it. Because when I write it down, it's going to be 3 stuff squared, isn't it? Because anytime you say the word stuff, right, you get to say, okay, well, it's 3 stuff squared. Now I'm going to write down the stuff. It's going to give me 3x minus 1 over x squared plus 3. Now, here's the problem. I said the word stuff. Okay? And anytime you say the word stuff, that means you're going to use chain rule. So when I say 3 stuff squared, chain rule means I have to take the derivative of the stuff. And guess what I get to use here? Quotient rule, right? It's a you're stuck. You have to use quotient rule. So I'm going to use quotient rule. Derivative of the top, which is 3, times the bottom, which is going to give me x squared plus 3, minus derivative of the bottom, which is 2x, times the top, which is 3x plus 1, all over x squared plus 3 squared.
Mr. Alvis, I have a question.
Yes.
Is it 3x minus 1 or 3x plus 1?
Oh, whoops. It's minus 1. I can't read. Now, yay, right? We've started with something that was this big, right? We took the derivative and now it's this big. And now we have to make it small again. We have to clean this up. So how do you go about cleaning it up? Well, the good news is this is actually easier to clean up than the previous problem, or at least I think it is. We just have to clean up the numerator. Let's see, that's 3x squared plus 9 minus 6x squared plus 2x. And so I end up with 3. And then I have 3x minus 1 over x squared plus 3 squared times, you get an x squared plus 3 squared, and 3x squared minus 6x squared gives me a negative 3x squared. I'll put a plus 2x and then a plus 9. And we're not quite done. Of this fraction, see how I have stuff squared? Right? Anytime you have a fraction squared, you can actually break this apart. You can say this is the top part squared and the bottom part squared. And the reason I want to do that is I can now combine these two terms, because they're the same, right? X squared plus 3 squared, x squared plus 3 squared. That gives me x squared plus 3 to the 4th. And then on top, I end up with 3x minus 1 squared times negative 3x squared plus 2x plus 9. Yay. Again, this is one of these examples that the calculus isn't so bad. I mean, once you get used to the chain rule and actually tomorrow when we do more practice with the chain rule, I think the chain rule will get a little easier. It's the algebra after the chain rule that's a bit of a pain. Actually, it could be a lot of a pain. There's lots of places to mess up. All right, so there's this one. Okay, next up. Okay, so I'll have y equals, okay, good. Let's do 2x minus 3 to the 4th times 3x plus 5 to the 5th. So has everybody done product rule combined with chain rule? Because I see stuff to the 4th and stuff to the 5th, so there's a whole lot of product rule, a whole lot of chain rule going on. All right, so I see 4 stuff to the 3rd. So my stuff is going to give me 2x minus 3. I got to remember the times 2. Copy this thing, so it's going to give me 3x plus 5 to the 5th, plus derivative of that, which is going to be 5 stuff to the 4th. And again, my stuff is 3x plus 5. I said the word stuff, so I got to take the derivative of that, which gives me a 3, times this thing, and that gives me 2x minus 3 to the 4th. Are we okay with that as our first step? Now, the fun and excitement is how on earth do you clean this up, right? This is a mess, right? It started off this big and now it's really this big. How do we make it a little smaller? And the good news is this is actually easier than the previous. I think it's easier than the previous 2 examples. I'm going to go through an intermediate step that most people could probably skip this next step. But I'm just going to combine them. Okay, that's going to give me an 8 times 2x minus 3 cubed times 3x plus 5 to the 5th. And then I get a plus 15 times 3x plus 5 to the 4th times 2x minus 3 to the 4th. All right, all I did was just combine those numbers, right? All right, and here's the trick. The trick is you ask yourself what's in common. I have 2 terms. In this term, I see that I have, in this term, I see that I have a 2x minus 3. Everybody see how that? And so what's in common is a 2x minus 3, and I have 3 of them here and 4 of them here, so I can pull 3 of them out. The next thing I look at is I have a 3x plus 5. Right? I've got one in this term, and I've got some in this term, and I've got some in this term. So I have 3x plus 5, and I can pull 4 of them out. And now the trick is, well, what's left inside? Well, let's see, there's an 8. Let's see. I took out all of these and 4 of those, so I've got a 3x plus 5 plus. I took out all 4 of those. There's still a 15. And I took 3 of those out, so that's going to give me a 2x minus 3. And now I've got to clean this up. So this gives me 24x plus 40 plus 30x minus 45. So 24x and 30 is 54x minus 5. So all of that cleaned up to this. just have the rest of this, which is a 2x minus 3 cubed and a 3x plus 5 to the fourth. So it's going to start off as x over the cube root of x squared plus 4. Okay, now, what do you see first? What am I going to do first?
You can take the, you can make it root 1/3.
So I can change this to a 1/3, right? Right, because that's what you need stuff raised to a power, right? But what are we going to do first? What do you see first? Quotient rule. Like the first thing you see is a fraction, right? You see that compared to the other one? Like the other one, even though you saw a fraction, it was stuff raised to a power. This is clearly a fraction. And if it's a fraction, sorry, you're stuck. You got to use quotient rule. So what does that look like? It's not pretty. It's the root of the top, which is 1, times the bottom, which is this x squared plus 4 to the 1/3, minus the derivative of the bottom, which is 1/3, copy stuff, x squared plus 4, subtract 1 from that, I get a negative 2/3 times 2x, all over the bottom squared, which is x squared plus 4 to the 1/3, all of that squared. So whoops, times x. So if this is an f, if this top's the f and the bottom's the g, this is f prime, this whole thing is g, and then this whole thing is g prime, and that's f. And of course, that's going to be g squared. And it's easy to get lost. Well, yay. This is hideous. This is just absolutely ugly. So what do? Well, you got to deal with the negative exponent, and as far as dealing with the negative exponent goes, I want to make sure you don't do this very common and bad mistake. You see a negative exponent, you can't put this down to the bottom because you're subtracting, adding, subtracting here. So you're stuck. So when I rewrite it, this is going to give me x squared plus 4 to the 1/3 minus, this is going to create a fraction up here. That's a 2x squared on top. I get a 3, and I get an x squared plus 4 to the 2/3 on the bottom, all over x squared plus 4. And exponent raised to an exponent means that it multiplied, so I end up with 2/3. I have it clean. I'm not done. All I've done is taken care of the negative exponents. Believe it or not, this final answer ends up being pretty small. All right, so what do? Well, how do you clean this up? And you may not believe this, but we're going to clean this up in basically one step. One step and a little bit, and then it's going to be this big. Right? So here's kind of the logic of whenever I see layered fractions, your final answer can never be layered fractions. You got to clean this up. And my issue with this whole expression is basically that denominator. Like if I could get rid of that denominator, then this is going to look a lot better. And so how do you get rid of that denominator? Well, here's the trick. The trick is get rid of it. Like, how do you get rid of that denominator? Well, I'm going to call this kind of an advanced algebra trick. You may have had, your pre-cal teacher may have done it. Your algebra teacher may have done it. But here's the trick. Anytime you have a fraction, you're allowed to multiply top and bottom by the same thing. And so what I'm going to do is I'm going to multiply by 3x squared plus 4 to the 2/3. 3x squared plus 4 to the 2/3. I'm going to multiply top and bottom by 3x squared plus 4 to the 2/3, and something very nice happens very quickly. I've got to.
Oh wait, on that 2x, isn't that supposed to be 2x squared?
Yes, it is. Thank you. Ahead. All right. This is the part that's, as ugly as this is, doing this little trick cleans a whole lot up. So let's look at it. Well, the bottom isn't terrible. Like, our bottom is just going to be, well, there's a 3, and this thing times this thing. I get to add the exponents, so it's going to give me x squared plus 4 to the 4/3. Here's the interesting part with the top. Are we okay that if I multiply this thing times the first part, it's going to cancel, so I'm just going to get a 2x squared? So, I mean, that makes it, that's pretty nice. And what you may not realize, right, and it doesn't just happen in this case, it pretty much happens every case. What happens when this gets multiplied times this? So in my head, what I see is I've got x squared plus 4 to the 1/3 times 3x squared plus 4 to the 2/3, right? So I've got the 3. And when I multiply x squared plus 4 to the 1/3 times x squared plus 4 to the 2/3, I get x squared plus 4 to the 1st. So what ends up happening is this times this just gives me 3 times x squared plus 4. Which is really nice, right? This cleans up incredibly nice at this point, because I've got 3x squared plus 12 minus 2x squared. So my final answer is x squared plus 12 all over 3 times x squared plus 4 to the 4/3. And I end up with a pretty nice answer, something that you may not realize, this ugly thing would simplify to this. All right, here is my warning, because I've got like 2 minutes